Good day, everyone. I'm Ken Tristisi Kamay, and I'm going to report Chapter 21 Pavement Condition Prediction. So, the results of pavement rating measurements can be used to predict pavement condition in future years when data are collected over time. The results can be used to develop mathematical models that relate pavement condition to age of pavement. Condition prediction models are essential to the pavement management process at both the network and the project level. At the network level, prediction model forecast the future condition of the network and the basis of budget planning, inspection scheduling of maintenance, and the rehabilitation activities. At the project level, prediction models are used in specific project life cycle cost analysis to select the most cost-effective maintenance and rehabilitation strategy. Prediction models are used in forecasting deterioration trends of pavement sections before and after major rehabilitation strategy has been selected. For example, these models can predict the condition of newly constructed sections as well as the condition of overlaid sections. There are two main approaches that have been considered to develop prediction models for pavement. Number one is the deterministic models, which are developed through regression analysis. And second one is the probabilistic models, which are based on tables that furnish the probability of pavement rating change from one year to the next. So, deterministic models. Many states accumulate pavement distress data for specific roadway sections. As inspected, with aging of pavement, the distress rating will decrease. In the figure 21.4 illustrates the variation in pavement condition versus age of pavement in the state of Washington. Note that there is a wide range of results which suggest that a pavement model should only be used in circumstances similar to those which existed when the data were collected. Example is the climate, subgrid strength, and the axle loads, etc. Prediction models can be used to predict future pavement condition, information that is required to determine appropriate rehabilitation program. So a variety of approaches have been proposed to develop regression-based prediction models. Two of these approaches are presented. Number one is the family-based and the multiple regression. So, family-based prediction model. This approach is referred to as family-based because pavement sections are segmented into groups or families in such a manner that all pavement sections in a specific group or family have similar deterioration trend characteristics. Group selection is based on factors such as pavement ranks, traffic volume, climate, structural strength, and surface type. Having defined each group or family of pavement sections, regression analysis is used to develop a separate prediction model for each family. The dependent variable is the pavement's condition index or PCI, and the independent variable is the corresponding number of years or age since the pavement was constructed, or this approach is referred to as a family-based because different pavement sections are segmented into groups or family in such a manner that all pavement sections in a specific group or family have similar deterioration trend characteristics. Having defined each group or family of pavement sections, regression analysis is used to develop a separate prediction model for each family. The dependent variable is the pavement condition index (PCI) and the independent variable is the corresponding number of years age since the pavement was constructed or re- resurfaced. The single independent variable age is sufficient to predict pavement condition since all other variables are classified and thus similar for these data sets or family. Pavement section have already been grouped into families with similar deterioration trends, thus accounting for other factors that affects deterioration. This technique is used for the prediction models in micropaver, a pavement management software package developed by the U.S. Army Corps of Engineers. Pavements are divided into family based on factors such as pavement type, asphalt concrete, Portland cement concrete, or asphalt concrete overlay, etc. Pavement classification, primary, secondary, etc. And climatic condition. For each family classification, micropaver generates a data file that includes pavement section, identification, age, and pavement condition index (PCI). Micropaver contains a feature that allows the user to remove incorrect data points and outliers. The technique produces a mathematical fits to the data as a polynomial regression. This method for modeling curvature in a relation between a response variable y and a predictor variable x extend a simple linear regression model by including x squared and x cubed predictors. Thus, the micropaper model is expressed as follows. So, micropaper model expressed as p of x is equals to a0 plus a1x plus a2x squared plus a3x cubed plus a4x to the fourth. So, where P of x is the pavement condition index or PCI, and the x is the pavement age in years, and the A01234 is constant, is equals to constant. By using the transform variable x squared, x cubed, and x4, a nonlinear model can be created using simple linear regression. The form of the model must be specified in advance. A characteristic of polynomial regression is that an increase in the slope of the curve can occur which contradicts the physical relation that the pavement condition cannot improve as age increases. Micropaver recognized this anomaly by imposing constant on the regression to eliminate the contradict. Example, developing a family-based prediction model. So in table 2.4, the following page lists inspection data that were recorded for a subset of pavement sections that are part of the statewide highway network. The pavement condition index (PCI), the number of years since construction's age, and the average annual daily traffic, and the structural numbers is listed for each section. Develop a family-based prediction model based on the pavement section data in table 21.4. Yeah. The solution is based on the data shown in 21.4. The 8 pavement sections are divided into two families based on solely on the AADT values, since the values of 4 DSNs are not sufficiently distinctive to warrant further classification based on this independent variable. AADT values are segmented into two categories. One is the section with an ADT greater than 10,000 V per day per length, and the section with ADT is less than equal to 10,000 V per day per length for lane. So this is the table 21.4. Here you can see the polynomial regression. Polynomial regression is used to develop the regression models using an x squared term, such as that the regression is model is pavement condition index is equals to a a0 plus a1 times the age plus a2 times the age squared. Since regression belongs to which families are shown in tables 2.1 2.6 with the new variable age squared added. So this is the table 21.5 and the table 21.6. So this is 21.5, the family 1 sections where the AADT is greater than 10,000. Then the table 21.6 family is the family 2 sections where the AD or AADT is less than equal to 10,000. So a spreadsheet or statistical analysis software is used to determine the constant value A in the prediction model based on the data in table 21.5 and table 21.6. The results are family 1 AADT is greater than 10,000. So PCI is equals to 99.84 minus 3.04 times the age and plus 0.12 times age squared. The r squared is equals to 0.99. So the value r squared equals 0.99 indicates a very good fit between the model and the data. This can be demonstrated in figure 21.15, which shows a plot of the model results versus the actual data. In the family 2, where the AADT is less than equal to 10,000, PCI is equals to 99.74 minus 3.99 times age plus 0.12 age squared, where the r squared is equals to 0.99. So again, the value r squared is equals to 0.99 indicates a very good fit between the model and the data. This can be demonstrated in figure 21.16, which shows a plot of the model results versus the actual data. So this is the data graphic of the family 1 and the family 2. This data graphic. Yeah. Example, pag- when you solve the age when the pavement ray facing is required. So determine the number of years before a pavement section belongs to family 2 is equal to ADT is less than equal 10,000. In example 21.3, we'll need to resurface if pavement overlays are necessary when the PCI value falls below 74. So the solution is using the model previously. develop in equation develop in the equation 21.7, determine the age at which the section will reach us reach a PCI of 74 as follow. So 74 is equals to 99.74 minus the 3.99 times the age plus 0.12 times the age squared. So therefore 0.12 times age squared minus 3.99 times age plus 25.74 is equals to 0. Solve this quadratic equation as follows. So age is equals to 3.99 minus the square root of 3.99 squared minus 4 times 0.12 times 25.74 over 2 times 0.12 is equals to 8.75 years. So, muna itong age ni Ja. So, next is the multiple regression prediction model. In contrast to family-based prediction model, which relates an element's condition index to a single independent variable, multiple regression prediction model relates the pavement condition index for a given highway section to several factors that affects deterioration such as age, usage level, climatic and environmental condition, structural strength, and construction materials. An example of multiple regression model follows. So, example 21.5. Developing a multiple regression prediction model. So, develop a multiple regression type model using the data shown in 21.4. The form regression model is shown as equation in equation 21.8. So, Ci equals to A plus B times the age plus C times AADT plus D times the SN. So solution, a spreadsheet or statistical analysis software is used to develop the prediction model based on the data in table 21.4. The results are shown in equation 21.9. Yeah, so Ci is equals to 101.48 minus 2.46 times age minus 0.5 times 10 power of negative 3 times ADT plus 0.81 SN. Now R squared is equals to 0.97. So the value of R squared is equals to 0.87 indicates a very good fit between the model and the data. So this is the data and probabilities of pavement condition changes. Naman yan data to the PCR stated. Next is the probabilistic model. Probability methods are based on the assumption that future conditions can be determined from the present state if the probabilities of given outcomes are known. An example of this approach is Markovian model illustrated in table 21.17. It shows the probability that a pavement condition in state I will change to a pavement condition in state J. For example, If the current year of the pavement condition PCR is within 70 to 79, state 7, then the probability is 0.3 that in the next year of the pavement condition will be in 60 to 69, state 6. The probability shown in table 21.7 can be used for successive years in a so-called Markovian chain. The assumption of the Markovian models in is that future state is dependent on the current state regardless on how the pavement reach that current state. Next is the pavement rehabilitation. A variety of methods can be used to rehabilitate pavement or to correct deficiencies in a given pavement section, including using overlays, sealing cracks, using seal coats, and repairing potholes. Next is the rehabilitation techniques and strategies. Rehabilitation techniques are classified as one is corrective, which involves the permanent or temporary repair of deficiencies on an as needed basis. Second one is the preventive, which involves surface application or either structural or non-structural improvements intended to keep the quality of the pavement above a predetermined level. Corrective maintenance is analogous to repair a small hole in whereas preventive maintenance can be thought as a sewing a large patch of replacing and leaning in a suit, just as when the winning analyzed corrective measures can be served as prevention measures too, as well as to illustrate sealing cracks than correct the existing problems, but it also prevent further deterioration that would occur if the cracks were not repaired. Similarly, a chip seal coat, which which is a layer of gravel placed on a thin coated of asphalt, is often to use to correct a skid problem but also helps prevent further pavement deterioration. Pavement rehabilitation strategies can be categorized in variety of ways. One approach is in terms of the problem being solved, such as skid resistance, surface drainage, unevenness, roughness, or cracking. Another approach is in terms of the type of treatment used, such as surface treatment, overlay, or recycle. A third approach is in terms of types of surface that will result from the process, such as asphalt overlay, rock seal coat, or liquid seal coat. The latter approach is the most commonly used because it enables the designer to consider each maintenance alternatives in terms of final product and then select the most appropriate one in terms of result, desire, and cost. Thus, the repair strategy information provides a means by which the problem and hand can be identified and the most economical alternatives based on cost, and life experiences expectancy can be selected. Second is the alternative for repair and rehabilitation. In figure 21.17 illustrates a variety of pavement repair and rehabilitation alternatives and different differentiates between preventive and corrective approaches. For example, preventive strategies for pavement surface includes fog seal asphalt, rejuvenators, joint sealing, seal coats with aggregates, and a thin blanket. This figure is provided to assist understanding the proposed for which a given treatment is intended. There are a variety of pavement rehabilitation techniques for both flexible and rigid pavements, and they may be corrective or preventive depending on the circumstances. For example, patching is always considered to be the corrective and can be effective if properly done. Many patching materials are available. At the other extreme, overlay are both corrective and preventive and considered to be an effective technique. Surface treatments can be either preventive or corrective, and are considered as an effective means of maintaining roads on a regular basis. So, this is the pavement and pavement maintenance and rehabilitation flow chart. So, in maintenance, there are two categories, surface and subsurface. In surface, napadjay two types, the preventive and corrective. Mga na, tuloy na. Nasa surface, sa preventive media, natay fog seal, asphalt, rejuvenators, joint seal, seal coats with aggregates, thin blanket. So corrective, patching, crack filling, joint sealing, seal coat with aggregates, friction cores, groving, thin blanket, surface recycling, cold planning, drainage. In the subsurface, naputay preventive and corrective kalay anja. Sa preventive na drainage. Sa corrective na subsealing, in situ stabilization, mudjacking, routing injection, and drainage. So in the structural rehabilitation, there are two. There are three die. Reconstruction, overlays, and recycling. The overlays, they are asphalt, concrete, both dense and open graded, Portland cement concrete. Note that includes use of untreated aggregate layers, fabrics, membrane, and interlayers. Recycling. In place recycling with or without admixture. Central plant recycling with or without admixtures. And napay usa combination recycling and overlays. Ija kay surface recycling and overlays. So another method of describing pavement rehabilitation alternatives is to identify differences and select the most appropriate treatment. If this if these stress types are known in terms of severity and if refers is considered temporary or permanent, then a repair strategy can be selected. For example, for flexible pavement, alligator crack is repaired repaired by removal and replacement of the surface cores, by permanent patching or scraping and mixing the materials with asphalt. The state of the practice of pavement rehabilitation have been considered advanced in recent years as a result of research on long-term pavement performance supported by the Strategic Highway Research Program during 1990s. A list of reports prepared through this program is available on the Federal Highway Administration website at www.fhwa.dot.gov. That additional reports produced by National Cooperative Highway Research Program or NCHRP of the Transportation Research Board are available on the website www.trb.org. That's several relevant NCHRP synthesis reports are listed on this chapter. Diha tanga website ang atong nakuha ning kuan ning pavement rehabilitation. So next topic, the core system as a tool to select maintenance and rehabilitation strategies. So expert system is a branch of artificial intelligence, can be used in selection of maintenance and rehabilitation strategies. Expert system are computer models that exhibit within a specific condition a degree of expertise in problem solving that is comparable to that of a human being. The knowledge required to building an expert system is obtained by interviewing pavement engineers who have long experience and knowledge about pavement management. The acquired knowledge is stored in the expert system, which can be used to recommend appropriate maintenance or rehabilitation stages. Since the information is stored in a computer knowledge base, diagnostic advice is available to those users who may not be as experienced. So, next is the pavement rehabilitation program. So, in previous sections, we describe how pavement condition is measured and discuss the alternatives and strategies available to to repair and rehabilitate these surfaces. In this section, we describe the process used to decide upon the specific program of rehabilitation. This requires decision about the type of repair or restoration technique that should be used for given pavement section and about the timing or programming of the project. This decision consider the design life of the pavement, the cost and the benefits of the project, and other physical and environmental conditions. Transportation agencies use various methods for selecting programs of pavement rehabilitation according to the AAS HTO guidelines for pavement management system. Analysis techniques are divided into three main groups. Number one is the condition assessment. Two is priority assessment, and the three is optimization. In Table 21.8 reports on analysis techniques used or in the planning stage by state highway agency in the early 1990s. Each method is used to determine the type of treatment needed and the schedule for rehabilitation. The following section describe each method. So this is the table 21.8 of the pavement management analysis techniques for state highway agencies. So techniques none numbers of 4, condition of priority numbers are 37, optimization numbers are 22. Mo niyang table niya. So next is the condition assessment. This method is used to develop single-year programs. The agency establishes criteria for the different measures of the pavement condition, against which comparison of the actual measurements can be made. If the measurement exceed this limit or trigger point, then a deficiency or need exists. In figure 21.18 illustrates this concept. For example, if a limit of PSI of 22.5 has been set as the minimum acceptable roughness level for a particular class of pavement, then any section with PSI less than 2.5 will represent a current deficiency. The fixed trigger point thus resolves the timing issue in a simple manner. Whenever the condition index falls below the given trigger point criteria, it is assumed that rehabilitation is needed. Therefore, by using the trigger criteria, all sections are separated into two groups, now and later needs. In these methods, the concern is only with the now needs, having decided upon the sections that need action. The next step is to select a treatment for each of the now needs. This involves simple economic analysis methods such as the net present worth or benefit cost ratio, based on an approximate statement of the expected life of the different alternatives. After deciding on the treatment, there are three possible situations may arise. Number one is they need to match the budget. The needs exceed the budget, and the third one is the needs are less than the budget. So, of the three situations, the most common occurs when need exceed the well available funds, and so a ranking of this project is often needed. The purpose of such ranking is to determine which needs could be deferred to following year. There are several possible alternatives for ranking. Project may rank by distress, a combination of distress and traffic, the net present worth, or the benefit cost ratio. Sections are then selected until the budget is exhausted. So the rational factoring ranking methods, or FRM, is example of a ranking method. It uses a priority index that combines climate condition, traffic, roughness, and distress. The priority index is expressed as y is equals to 5.4 minus 0.0263 x1 minus 0.0132 x2 minus 0.4 log x3 plus 0.749 x4 plus 1.66 x5. So where y is equals the priority index ranging from 1 to 10, with 1 representing very poor and 10 representing excellent. Thus, a value indicates a pavement has a high priority of for treatment. So x1 is the average rainfall inches per year. Then x2 is the freeze and thaw cycle per year. The x3 is the traffic. x4 is the percent service ability index. And x5 is the stress, a subjective number between -1 and +1. So, example, in determining the order of priority rehabilitation, there are three sections of highways have been measured for surface condition with results as shown in table 21.9, also shown as climate and traffic condition for each section. Use the rational factorial rating methods to determine the order of priority of the repetition. The solution using the equation 21.10. So y is equals to 5.4 minus 0.26 x1 minus 0.132 x2 minus 0.log x3 plus 0.749 x4 plus 1.66 x5. So the priority index y for section is there are three sections man. So substitute ra ja magkuha ta diri sa table 21.9. So substitute ra x1 merni 10 diri 10 nada ja 5 10,000 ja 2.24 ja 0.05 plus is equals to mora po diri i-substitute diri sa table 21.9 to sa ang section 1 to 3. Ja, since low index values indicates poor condition in section 2 receives highest priority followed by section 1 and last is section 3.